All right, folks, 1 cubic, so let's do number 23. So this of aluminum, 1 centimeter cubic of aluminum has a mass of 2.7 times 10 to the 3 kilograms. So a specific volume has a specific mass, so that implies the density. So that means that this density, I'm just going to call it P, let me see, what do they call it? P aluminum. I'm going to change this a bit on the next problem because it's really the same thing. So the density of this is really just 2.70 times 10 to the 3 kilograms per meter cubic. That's just a density value. And then the same volume of iron. So the density of iron has, let me clean that a bit. There we go. It looks a little better. Has 7.86 times 10 to the 3 kilograms per meter cubic. Find the radius of the solid aluminum sphere that would balance out with the iron. Okay, so it's a sphere. And I believe that wait, what? Find the radius of the solid aluminum sphere that would balance. Well, this is meter cubic, so we're gonna have to find the volume of the sphere, which is 4/3 pi r cubic, I believe. So, anyways, let's read the problem. So this is the volume of a sphere. So the volume of the sphere times this is the mass, but the question is asking find the radius, which we're not going to know, of a solid aluminum sphere that will balance out with the mass. So in other words, if it's saying the word balance, that implies that the mass of the aluminum has to balance out with the mass of the iron. So in order to get the mass, you just multiply by the density multiplied by its volume. So what we're going to do is we're going to take the density of the aluminum multiplied by the volume of the aluminum, or in this case 4/3 pi r cubic of the aluminum, and we're going to multiply by the density of the iron. And this would be 4/3 pi r cubic of the iron. So the reason why I'm doing this first, folks, is because, oh, and they do give one of the values. That would balance, okay, so the radius of the eye is given, which is 2 centimeters. So we're given this, and it's just asking us to solve for r cubic of 3. So this cancels off. So we'd be left with the RA being, I hope you guys are finding this pretty straightforward. If you're lost, that means that you need to brush up on your algebra rules, because that's all this is. I remember when I took my first physics class, I didn't know anything. But that's not because you guys are stupid. It's because, sometimes we're not taught things properly. Anyways, so we're going to solve for the radius of the aluminum, which is going to be this, the density of the iron divided by the density of this, and I'm doing this algebra, 1/3 cubic, since we're going to 1 cube, and this is going to be, so I guess this is just this multiplied by the radius of the iron. So that's really the formula I set up for you guys, which we're just going to copy and paste it on the other one. All right, let's solve this. So let's take 2.70 times 10 to the 3, and says we're going to, oh, I meant to put the other one. 7.86 times 10 to the 3. Realistically, you could just cancel these guys off. And since the units cancel off, we don't have to really worry about the units either. So just take this value, divide it by 2.7, multiply it by 2 centimeters, 200 centimeters. Keep the units, and that should give you the radius of the aluminum. And that radius of the aluminum that we're about to solve is going to be 7.86 divided by 2.70, multiplied by 2, double that value, 5.82 centimeters. And let me check my answers in here. What the heck? Apparently it's wrong. I'm not sure why. Oh, that's because I didn't... Oh my god, I'm an idiot. I know why. Good thing I checked there. There you go. Beautiful. What's funny is I actually had the right formula, but I checked it in wrong like an idiot. All right, so 2.8. So embarrassing. I'm just gonna keep it as 5 centimeters. You don't even, the tradition says to round up when you have 5, but I really don't care. So round up or down, who cares? But that's anyways, folks.